Good day everyone. So for our reporting, we will be talking about liquids and its different properties such as fluidity, viscosity, and diffusion. Firstly, when we say liquid, it is a nearly incompressible fluid that conforms the shape of its container but retains a constant volume independent of pressure. As such, it is one of the four fundamental states of matter and is the only state with a definite volume but no fixed shape. The particles found in liquids don't interact with one another but just hit and bounce off each other when they collide. Furthermore, liquid is a transparent, odorless, tasteless form of matter, a compound of hydrogen and oxygen, H2O, freezing at 32 Fahrenheit or 0 Celsius and boiling at 212 Fahrenheit or 100 Celsius. That in a more or less impure state constitutes rain, oceans, lakes, rivers, and etc.
Okay, so with viscosity, it is the resistance of a fluid, liquid, or gas to a change in shape or movement of neighboring portions relative to one another. It describes the internal friction of a moving fluid. A fluid with a large viscosity, it resists motion because its molecular makeup gives it a lot of internal friction. A fluid with low viscosity flows easily because its molecular makeup results in a very little friction when it is in motion. A very good example of it is a cup of water and a jar of honey. If you transfer the water into an empty one, the flow of the substance will be faster as water does not resist motion. On the other hand, if you pour honey into a cup, the flow will be much slower since honey is a viscous liquid. In that matter, it resists motion because its molecular forms gives it a lot of internal friction.
Fluidity is defined as the nature that concrete mixtures, under the influence of self-weight and mechanical vibration, start to flow and fill every corner of the moldboard evenly and densely. Fluidity is the reciprocal of the coefficient of viscosity. Just like viscosity, the higher the viscous the fluid is, the slowly it will flow. And fluidity is defined as the ability of a liquid to flow readily, whereas a fluid is a substance that atoms or molecules are free to move past each other and therefore can take the shape of the container.
So for diffusion, it is the process of a substance spreading out to evenly fill its container or environment. In a solution, a concentrated solute diffuses to spread evenly in its solvent. This is a process where the particles move from high concentration to low concentration. So diffusion is defined as the movement of a substance from an area of high concentration to an area of low concentration. It only happens between liquids and gases because their particles move randomly from place to place. It is an important process for living things. It is how substances move in and out of cells. An example of diffusion is a perfume being sprayed in one part of the room. It diffuses so that you can smell it everywhere. And another example is a drop of food coloring diffuses throughout the water in a glass so that eventually the entire glass will be colored.
For the second part of our report, we are going to discuss how intermolecular forces are related to these properties of liquid. So first up is viscosity. It increases as intermolecular interactions or molecular size increases. So how does this happen? There is a correlation between viscosity and molecular shape. Liquids consisting of long, flexible molecules tend to have higher viscosities than those composed of more spherical or shorter chain molecules. The longer the molecules, the easier it is for them to become tangled with one another, making it more difficult for them to move past one another. London dispersion forces also increase with chain length. Due to a combination of these two effects, long-chain hydrocarbons, such as motor oils, are highly viscous.
Viscosity is the resistance of substance, liquid or gas, to changing shape or moving adjacent portion relatives to one another. The term viscosity refers to the resistance to flow fluidity. Fluidity is known as the reciprocal of viscosity, which is measure of flow is molasses, for example, has a viscosity that is higher than water, since a portion of a fluid that is forced to travel follows it to some degree.
Lastly, we have diffusion. If a chemical has high intermolecular attraction, generally a result of dipole-dipole or charge-dipole interactions, then only a few of the molecules will escape into the gas phase. The rate of evaporation for such molecules is low. Now, the example that we use for diffusion is evaporation. Now, strong intermolecular forces produce a lower rate of evaporation and a lower vapor pressure. Weak intermolecular forces produce a higher rate of evaporation and a higher vapor pressure. As the temperature increases, the vapor pressure increases. So as we all know, when liquids become heated, their molecules become agitated and therefore they move away from each other. Therefore, when the molecules move away from each other, they have weaker intermolecular force and increased vapor pressure, therefore a higher diffusion.
That is all. Thank you for listening.